Hello everyone. In this video, let's understand about the confusion matrix. Although this term confusion matrix has this word confusion, but it's not confusing at all. Alright, so let's get started and let's first understand the problem statement, why we use confusion matrix and where we can use confusion matrix in practice or in real world. Alright, so the problem statement is as follows. The employee attrition has always been a major problem for companies. Now, what exactly employee attrition is? When an employee decides to leave the company, okay, maybe because of XYZ reason, because of maybe another company is giving a higher salary, higher package, maybe the employee thinks that the learnability curve in that other company would be higher, or maybe the workplace or the office is near to the new office that he is looking. Because of XYZ reason, if an employee decides that he wants to leave company, so that would be a big problem for the current company because they would have to interview 10 different candidates for that one place. There would be a loss of some information as well, right? So they would have to interview more candidate. All right. Now, as a data scientist, you have to solve this problem. Now, what you have done as a data scientist, you have built a classification model, okay, that can predict if an employee is leaving, it will predict 1, and if the employee is not leaving, it will predict 0. Okay, why do we call it as a classification model? Because it is categorizing. It is categorizing into two categories. For example, if employee is leaving, it will say 1, yes, employee is going to leave. It will predict employee is going to leave, and 0 if the employee is not going to leave, right? That's why it's called the classification model. So in this video, we will not be talking about how to build this classification model. You can check out other videos on the intuition of logistic regression, intuition on decision tree. So there can be multiple classification models that you can use. For example, logistic regression is one model, one such model that you can use. Decision trees can be another model that you can use. Okay, so in this video, we will be talking about how to evaluate your machine learning model. You have built the machine learning model and it's working fine. It is predicting for an employee. If you provide an input to the model, it can predict the employee is going to leave or not, right? Not leaving. So it will just predict 1 and 0. Now the important question is that we have to solve, we are solving in this video, is how would you evaluate that the model that you have created is sensible? This would be an important question to ask. Why it's an important question? Because hey, I can create a model that can predict all 1 1 1 1 1 for all the employees. It means that I'm saying, hey, this employee is leaving, second employee is also leaving, third employee is also leaving, and all the employees are leaving. This is not a sensible model, right? Or in other case, I can just say, hey, no one is going to leave. Just predict 0 0 0 0 0 for everyone. Again, this is not a sensible model. So to put any model in the production, before putting any model into production, I need to evaluate how good the model is, how sensible the model is, how sensible these predictions are from this particular model. Or even sometime if you have 5 different models, let's say in a data science team, we have created 5 different models. Now, which model to put in production? We can evaluate all the 5 models using confusion matrix, and then the best model we can put it in production. All right. So what we have is something like this. We have a model, machine learning model. Okay. It can be logistic regression. It can be decision tree. It can be SVM, any model. What I'm concerned about, okay, this, I'll provide the employee features. I'll provide this as input. What are the features? Features can be what is the current salary of the employee, how many years this employee is working, maybe the work experience, okay, and what is the team he works for, and so on and so forth. The other features that you have for an employee, how you represent an employee, right? So if you put all these features as input, this is for one employee. Okay. Similarly, if you input another employee, features of another employee, right, this model will give you the prediction. It can give you whether the employee is going to leave or not leaving. So this is what we have. Okay. Now let's understand. Let's say there are 100,000 employees in a company, and the actual data says that 770 people did not leave the company in the next month, and out of 1000 people, 230 people left the company. Okay, but if you input these 1000 employees to your machine learning model, the machine learning model says that 800 people will not leave the company in the next month. Let's say, since we are predicting for the next month only, let's say 800 people did not leave, so it is predicting zero. It is predicting zero for 810 people, and for 190 people it is predicting category 1. Okay, this is the predictions you have from your machine learning model, and in actual what we have observed is 770 people did not leave, whereas 230 people left the company. Now I need to understand, is this model, the model that we have used here, is a sensible model or not? Is it a sensible model? Because you can see that there are some misclassification, right? But I want to understand in more depth, and that's why we will understand the confusion matrix and we will plot the confusion matrix. So the confusion matrix is actually a matrix. So for example, if you have two categories, right now we have employee will leave or will not leave. I have two categories. So the matrix that I will plot will be 2 cross 2. If you have three categories, maybe in any different situation or a different challenge, you can have three different categories. In that case, the confusion matrix would be 3 cross 3. If you have 4 categories, 4 cross 4. If you have k categories, k is a general term, then the matrix that you will plot would be k cross k. Okay. Now, since in this problem that we are tackling right now, there are two different classes, let's stick to only 2 cross 2 matrix. So this is how the confusion matrix look like. On the column side, we plot or we put the actual labels, actual categories. What are the actual categories? The actual categories were employee will leave 1, employee will not leave 0. So employee will leave, it's 1, employee will not leave, it's 0. On the rows side, on rows, we will put predictions. Now predictions can also be 0 if the model says that employee is not going to leave, and 1 if model says that employee is going to leave. Okay, and hence this look like a grid. Okay, this look like a grid. So what we observed from the data is for 1000 people, we had 1000 people. Model said that okay, few people will leave, few people will not leave, but in actual we saw that okay, these number of people left the company and these number of people did not leave the company. Okay, so let's understand and let's plot that data in the confusion matrix. So it looks something like this. So this number 730, it says that hey, your model is saying that these number of people will not leave the company. That's why it's 0. 0 means will not leave. In actual, what we observed that they didn't leave the company, and this is the 730. So these 730 people or employees, model said that they will not leave the company in the next month, and in actual they didn't leave, right? So it means the model is correct about these 730 people. So out of 1000, at least model is correct about these 730 people or employee. Look at these 150, what exactly this 150 is saying. So this 150 is saying that the prediction is 1. Prediction is 1 means model is saying they will leave, right? Model is saying that these people will leave, and in actual we observed that the next month they leave or they left the company. So it means again model is correct about these 150 people. Model is correct about 150 people, right? So out of 1000 people, I can see that okay, these 730 people plus 150 people, model is correct about these number of employees. But what about this 40 and 80? What about this 40 and 80? Let's understand this term 40, right? What exactly this number representing? The model is saying that these employees are going to leave. But in actual, what we observed is they are not leaving. So for example, if someone who is happy with his job, well settled, and so he's happy with the job, right? He will not leave the company. Why would he leave the company? But your model is saying that, hey, this person is going to leave in the next month, which is wrong, right? Similarly, look at this one, 80. Model is saying that these 80 people are not going to leave. Whereas in actual, what we observed is they left the company in the next month, which is again, model is wrong about these 80 people. So 40 plus 80. The model is giving wrong prediction for 120 employees. And for 880 people or 880 employees, 730 plus 150, for 880 people, employees, model is giving the right prediction, correct prediction. And hence we can say the accuracy of a model is 880 divided by 1000. That will become 88%. Okay, so it means that 88% accurate. We have the accuracy of a model 88%, and the error would be 12%. Okay, let's give the terminology to the confusion matrix. So this thing, so we can see that over here we have TN, then FN, FP, TP. Let's understand what exactly this TN, TP, FP is. So in the machine learning terminology, when we have two categories, 0 and 1, generally 0 category is termed as negative category or negative class. Okay, or negative category or label, you can say. 1 is generally called as positive category or positive class. So if you sum across this column, you will get 730 plus 40, that will become 770. Okay, and if you sum across this column, this will become 80 plus 150, 230. So it means in actual there were 770 negative people. Negative people as in they did not leave in actual. And in actual there were 230 positive people. So this is the total negative in actual data, and this is total positive in the actual data. 230 people actually left. If you sum across rows, this will be the prediction of 0, right? So this is 730 plus 80. This will be 810. Model said that 810 people will not leave the company. And if you sum across this row, this would be 40 plus 150. This would be 190. Model is saying that 190 employee will leave the company. Okay, so this is NP, negative, positive, and this is the prediction of the negative class. This is the prediction of the positive class. Now let's understand about this terminology. What is this TN? So this TN, there are two terms. There are two terms over here. The first is what your prediction is from the model. What the model is predicting. Now in this case, model is predicting class 0, and class 0 is termed as negative. So I will write N. So by the way, negative and positive. So positive, the term positive is not coming from a positive news. So here in this case, when the model is saying 1 means positive, right? But this is not a positive news for the company if employee is leaving. But this is general terminology, and don't relate this positive with a positive news. Positive is just because 1, and negative would be because it is 0. Okay, because this is 0. All right. So this first I need to put N. Why? Because model is predicting 0, and 0 means negative. Now this second term would be, is my model correct? Is model correct in the prediction? Whatever the model has predicted, is model correct in that prediction? So if the model is correct, then it means I need to put true. And yes, in actual it is 0. Model also predicted 0. It means this is true. Model is saying true, right? So that's why it's called true negative. Let's look at this term. It's TP, right? TP. So first, what model is predicting? Model is predicting class 1, category 1, which is positive. This is the prediction, right? This is the prediction from the model. Now, is my model correct? Yes, because model predicted class 1, and in actual, it's also class 1. It means model predicted that these people are going to leave, and in actual, these employees left the company. That's why it's true positive. Look at this one, right? Look at this FP, right? What your model is predicting? Model is predicting that these people are going to leave. That's why positive. Class 1, right? Class 1. But is this model correct? No. In actual, they did not leave. These employees did not leave. And that's why it's false. It is kind of, we call it as false positive. It is kind of false alarm. You're saying that, hey, these 40 employees are going to leave, right? These people are going to leave. But in actual, they're not leaving. They're happy with the job. So you will be putting a lot of extra resources for retaining these employees, right? And that's why it's called false alarm. You're generating an alarm that, hey, make sure that these employees will not leave, but they're not leaving. They're not leaving, right? They're happy with the job. That's why they're called as false positive. Look at this one. This is false negative. What you are predicting? Class 0. They will not leave. You're saying employee will not leave. Negative. All right. But in actual, they left the company. It means you're telling wrong, right? The model is predicting wrong. So that's why it's false. And this is the most critical number. Why? Your model is saying that, hey, these employees are not going to leave. So be relaxed, right? But in actual, they left the company. In actual, they left the company and we wanted to retain these employees. That's what the purpose of the machine learning model is, right? That identify those employees who are going to leave and retain them so that we can put energy, resources in retaining them. But the model is not able to predict. Model is saying that, hey, these people are not going to leave, which is wrong. And hence, this would be very, very important number. I want this number to be very low. Ideally, it should be 0. That no employee is left. Like if the employee in actual is leaving, then the model is not predicting wrong. Model is not predicting that he's not leaving, right? So ideally, these two numbers, false predictions, false positive and false negative, ideally they should be very low. Ideally, they should be 0. Ideally, it should be 0. But we should have a model having false positive and false negative to be as low as possible. And these two numbers, Tn and Tp. So always remember the diagonal element should be very high. The diagonal element should be high and the off element, the rest of the element should be very low. Then I will say that my model is sensible. So if you want to compare two models, just plot the confusion matrix for these two models and observe these false positive, false negative, true positive. The diagonal element should be higher. And if you're concerned about these employees, for example, these are those employees, the model predicted that these are not leaving, but in actual, they left. So this is the most critical number. I want this number to be as low as possible, right? And that's how we can plot the confusion matrix. We can evaluate a machine learning model. And the accuracy of this model would be Tn plus Tp divided by all the numbers, divided by Tn plus Tp plus Fp plus Fn. And this would comes out to be 88% because we have already seen that 730 plus 150 would be 880 and hence the accuracy would be 88%. I hope you liked this video and you got to know about how to evaluate a machine learning model, or in general if you want to compare two machine learning models.